Good morning, children. Today we will discuss about the preparations of the benzene. Okay. Last time we had discussed how the structure of benzene was derived. Now today we will discuss the preparation of benzene. Okay. Among that, the first one is cyclic polymerization. Cyclic polymerization. This we had discussed when we were doing the previous chapter about how when we were discussing about the alkynes, how alkynes could be used to obtain benzene. Okay. So alkynes, alkynes, usme bhi ethyne we are talking about. Okay. So 3 molecules of ethyne. I am just putting it in this manner so that you can understand the structure, okay, of benzene. So what is happening? You will find that one of the bond or one of the pair of electron gets in between them here and here. Okay. So when 3 molecules of ethyne, you are heating it at very high temperature using red hot iron tube, you will find the cyclization process take place and you get the benzene. Okay. Either this way or we can write it is having a structure of this kind. So this is how benzene is obtained by the cyclic polymerization of ethyne molecules. Okay? So this is the first method for the preparation of benzene. Okay? Then the second method for the preparation of benzene is by the reduction of phenol using zinc dust. By the reduction of phenol using zinc dust. Okay? Reduction of phenol using the zinc dust. So you take phenol, okay, this phenol you treat it with zinc dust. So you will find the reduction takes place and you will obtain benzene with ZnO. So this is the second method for the preparation of benzene. Okay. The third method for the preparation of benzene is from aromatic acid. Aromatic acid. Now which is the aromatic acid? You have learnt about it is the benzoic acid. Okay. So this is the structure for benzoic acid. This is benzoic acid. Okay. So benzoic acid, when you treat it with NaOH, you will get the corresponding salt of the benzoic acid. This is an acid, this is a base. Acid base reaction will take place and you will get the corresponding salt, which is sodium benzoate. The name of this salt is sodium. It is sodium benzoate. Okay. Sodium benzoate. Sodium benzoate, when you treat it with soda lime, sodium benzoate, COONA. This is sodium benzoate. You treat it with soda lime. Soda lime is actually the mixture of CaO and NaOH. NaOH, CaO taken in the ratio of 3:1 ratio, you heat it. So what will happen? The NaO will, that is here, this part of the molecule is removed in the form of Na2CO3, sodium carbonate. So what is remaining? It will be benzene. This hydrogen will get attached here and you will get the benzene. So you get benzene and sodium carbonate, benzene plus sodium carbonate. So this is how you obtain benzene by different methods, okay, from cyclic polymerization of the thine molecules, either reduction of phenol, okay. So this is your phenol, reduction of phenol giving you benzene plus zinc dust. Then you have the sodium benzoic acid, first gets converted into sodium benzoate salt, and that salt you treat it with soda lime. Soda lime is a mixture of NaOH plus CaO. It is taken in the ratio of 3:1, and this mixture is known as soda lime. Okay, so treating it with soda lime, the removal of Na2CO3, sodium carbonate will take place, and you get the benzene ring. Okay, so these are the three methods for the preparation of benzene. Okay, you can note this down. Then we can learn about the reactions of benzene. Okay. Now let us learn the chemical properties of benzene. Okay, chemical properties of benzene. So benzene undergoes various chemical properties. उसमें से एक है, it undergoes electrophilic substitution reaction. That means an electrophile is added, it's not added, rather it's substituted for the hydrogen of the benzene ring. Okay. So what is happening? Benzene ring. Okay. Let me take the electrophile as E plus. So this E plus will get added to the benzene. Electrophilic substitution is taking place, and you get the corresponding substituted benzene. Electrophile is substituted there, and this occurs in the presence of a catalyst. Okay, and there are 5 different electrophilic substitution reaction which you are going to learn. 5 different. Okay. So let me write the different electrophilic substitution reaction first. Okay, electrophilic substitution reaction. So as the name suggests, an electrophile is substituted on the benzene ring. उसमें first है nitration. Okay, nitration is one of the reactions which is electrophilic substitution reaction, where the electrophile is NO2 plus. So this is your electrophile. Okay, this is the electrophile. Okay, and the nitration mixture. Okay, nitration mixture is concentrated HNO3 or fuming HNO3 you can write, plus concentrated H2SO4. So this is the nitration mixture which you use, okay, to obtain the NO2 plus electrophile, and this electrophile substitutes on the benzene ring. So this is the first type. Second is sulfonation reaction. Which is the electrophile here? The electrophile here is SO3H plus. Okay, and the mixture, sulfonating mixture is it is concentrated H2SO4. Yeah. Fuming H2SO4, that is better word, that is better way to say, fuming H2SO4. Okay, so this is the second one. Third is halogenation. Okay, third type of electrophilic substitution reaction is halogenation. Okay, halogenation mein, which is the electrophile? The electrophile is the halogen ion X plus. Here X can be either Cl, Br, I. okay, Cl plus, Br plus, I plus, any of them. Okay, so this is your electrophile, and which is the halogenating mixture, okay, that is Cl2 with FeCl3 or Br2 with FeBr3, or in case of both of them you can also use AlCl3. So this is the halogenating mixture. Okay, it has to be carried out in presence of a catalyst. So this is halogenating mixture, halogenation reaction. Then you have the fourth one, which is Friedel-Crafts alkylation. Okay, Friedel-Crafts alkylation. Okay, which is the electrophile generated here? The electrophile is CH3 plus, methyl electrophile. Okay, either it can be methyl or it can be CH3 CH2 plus this ethyl. So depending on that, the different alkyl halide you should choose, whichever electrophile you require. Okay, and the mixture, the Friedel-Crafts alkylation mixture is alkyl halide, any alkyl halide, CH3Cl or CH3CH2Cl, okay, in presence of AlCl3. This is your Lewis acid. So this is your mixture, Friedel-Crafts alkylation mixture. Then you have the next electrophilic substitution reaction, which we call as Friedel-Crafts acylation. Which is the electrophile generated there? The electrophile generated is CH3CO plus. Okay, how do you obtain the CH3CO plus? Either by CH3COCl in presence of AlCl3, okay, or you can use ये ethanol chloride है, acetyl chloride, either you call it as acetyl chloride or ethanol chloride, CH3CO twice O. This is acetic anhydride in presence of AlCl3. Okay, so this is acetic anhydride. This is acetyl chloride. Okay, so this is the 5 different kind of Friedel-Crafts alkylation, Friedel-Crafts acylation, then you have halogenation, sulfonation, nitration. 5 different electrophilic substitution reactions which the benzene undergo. So you can note this down, and then now we can go into each one of them and show how the reaction will occur. Okay. Now let us discuss the mechanism of electrophilic substitution reaction. We will not go into very detail, just I will write the steps. So mechanism of electrophilic substitution reaction. Okay, उसमें सबसे पहला स्टेप है जनरेशन ऑफ इलेक्ट्रोफाइल. ओके, एक एग्जाम्पल दे देते. व्हाट इज दिस जनरेशन ऑफ इलेक्ट्रोफाइल? सपोज वी आर टॉकिंग अबाउट हैलोजिनेशन. ओके, सो Cl2 I can write it as, we are discussing generation of electrophile of halogenation. Okay, halogenation. Okay, so Cl2 है तो Cl plus what is the catalyst used? Either it is FeCl3 or it can be AlCl3. Okay, so bond breaking, how does it take place? both these electrons will be taken away by the chlorine and the Cl plus ion is formed. Okay, this is the electrophile, and this FeCl4 minus species is also formed. So, this is how first step, that is generation of electrophile. Okay. Second one, formation of carbocation carbocation intermediate. So, what is happening? There is a carbocation generated because of this electrophile. So, how does that occur? Let us see for the same halogenation process. Okay, you can use this for your different electrophilic substitution reactions also. So, what is happening here? This is your benzene ring. Okay, you are having the electrophile Cl. So, what is happening? ये जो pair of electron है, it will be taken by the chlorine, and now you have see benzene ring. अब ये electrons तो chlorine के पास चला गया, तो ये दोनों तो ऐसे ही रहेगा. यहाँ पे attachment of chlorine has taken place. Okay, और यहाँ H है. Okay, and this particular carbon, ये जो particular carbon है उसके ऊपर एक प्लस चार्ज आ गया, क्योंकि क्लोरीन वहाँ अटैच हो, क्लोरीन ने ये इलेक्ट्रॉन उसकी तरफ ले लिया ना, तो ये कार्बन के पास इलेक्ट्रॉन्स की कमी है. सो दैट इज अ कार्बोकेटाइन जनरेटेड. ओके, सो दिस इज द कार्बन विच इज हैविंग अ पॉजिटिव चार्ज, वेयर यू कैन अंडरस्टैंड द फॉर्मेशन ऑफ कार्बोकेटाइन हैज टेकन प्लेस. ठीक है. ओके, नाउ व्हाट हैपेंस? थर्ड स्टेप इज द रिमूवल of proton from carbocation. Removal of proton from the carbocation. अब यहाँ पे क्या होता है? ये है तुम्हारा कार्बोकेटाइन. ओके, यहाँ से एक प्रोटॉन निकल जाता है. कैसे निकलेगा? देखो यहाँ पे ये जो है this pair of electron, it is given back here. Okay, so what is happening? यहाँ पे this is the Cl, this is the H, this is the H, and this carbon is having a positive charge. This is your carbocation. The pair of electron between C and H, no, it gets back here, and H will be removed in the form of H plus. So that is the removal of proton taking place. So now you have your electrophile substituted at the position, leaving behind proton. Okay, so this is the third step where you are removing the proton. Got it, everyone? Okay, so that is how this mechanism is taking place here. Now the mechanism takes place in that manner. Now let us study different reactions. So this is occurred. Now H plus ऐसे ही तो नहीं रहेगा. So what it will do? It will take away the electron नहीं Cl from here. What will this H plus do? H plus, I am writing it here before going to reaction. ये H plus तो ऐसे ही रहेगा नहीं ना. So H plus FeCl4 minus, ऐसा है ना. So it will take away, this H plus will take away the Cl and form HCl, and you will get back your catalyst, which is FeCl3. So this is how you are obtaining your catalyst back, and also you will get the product as HCl. So first let us discuss the electrophilic substitution reaction, which is halogenation. Okay, halogenation यही है जो हमने अभी डिस्कस किया. ये हमने स्टेप वाइज डिस्कस किया है. So we will write only the reaction now. Halogenation reaction. What is happening? Benzene ring. Okay, benzene ring plus Cl2 in presence of FeCl3 will have the product as Cl getting substituted there plus HCl. Okay, FeCl3 is the catalyst, it will remain as it is. So, this is how you obtain your halogenation reaction. Which is the second reaction? Second reaction is, say, nitration, let us take. Okay, nitration mein which is the electrophile generated? Nitration mein electrophile generated is NO2 plus. Okay, so that is benzene ring. Okay, plus NO2 आना चाहिए. So, which is your nitrating mixture HNO3, which is fuming HNO3, highly concentrated HNO3 in presence of concentrated H2SO4. Okay, there you obtain the corresponding nitrobenzene. Okay, so this is how you obtain your NO2 nitrobenzene. ठीक है. Third is sulfonation. Okay, sulfonation. Now sulfonation, what is the reactant mixtures? It is concentrated H2SO4, fuming H2SO4. Okay, so benzene ring, when it is treated with fuming H2SO4, fuming H2SO4, it will have the SO3H electrophile substituted, SO3H electrophile substituted on the benzene ring. Okay, so this is how you get your sulfonation. So you can copy this, then I'll go to Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay, the next set of reaction is Friedel-Crafts alkylation. So which is the reactant mixture here? It is alkyl halide in presence of AlCl3. So benzene ring, when it is treated with, say, methyl chloride, it is an alkyl halide in presence of AlCl3, which is a Lewis acid. It gives you, which is the electrophile generated in alkylation? It is the methyl carbocation or ethyl carbocation. Okay, so CH3 plus or CH3, CH2 plus, those are the electrophiles generated. Here there won't be any positive charge, it will be bonded to CH3, it will be bonded to benzene, giving you methyl benzene. Okay, methyl benzene, and जो हाइड्रोजन यहाँ से रिमूव हो जाता है, the product will be HCl. So this is Friedel-Crafts alkylation. Okay, Friedel-Crafts alkylation. The next is Friedel-Crafts acylation. Okay, we also write it as FC, Friedel-Crafts acylation. Friedel-Crafts acylation. The reagent here used is either acetyl chloride or acetic anhydride. So if you are using acetyl chloride CH3COCl in presence of AlCl3, then the product obtained is COCH3. Okay, COCH3 HCl plus HCl. Okay, this is when acetyl chloride is used. Acetyl chloride. ठीक है, अगर एसिटिक एनहाइड्राइड यूज किया है या एथेनॉइक एनहाइड्राइड, एसिटिक एनहाइड्राइड का फॉर्मूला क्या है? CH3CO twice O in presence of AlCl3. What is the product obtained here? It is COCH3, same thing. But here one more CH3CO with this O is remaining and the H, the byproduct here it will be CH3COOH, which is acetic acid. So these are the 5 electrophilic substitution reactions of benzene. Okay. Now coming to addition reaction of benzene. Next type of reaction, addition reaction of benzene. Addition reaction of benzene. So that we have earlier also discussed, जैसे benzene है, it undergoes addition reaction with hydrogen, okay, at high temperature, okay. At high temperature it will give you the addition product, but there should be a catalyst also. You will get the addition product, that is bond breaking takes place here, here and here. Everywhere hydrogen will get added up and you have the product cyclohexane. You have the product cyclohexane. This is benzene. Followed? This is one type of addition reaction. Okay. Next is benzene का addition with chlorine, 3Cl2. Okay, 3Cl2 in presence of sunlight, H nu, 500 Kelvin temperature. You will find the product as hexachlorobenzene. Okay, that is everywhere the Cl atom is getting bonded. Okay, so this is hexachlorobenzene. Okay, so benzene hexachloride you can call or hexachlorobenzene. Okay, so benzene hexachloride. Benzene hexachloride. This is another addition product. Okay. So these are addition reactions of benzene. Also benzene can undergo combustion reaction. Okay. Combustion reaction. Combustion reaction. So benzene, which has the formula C6H6, reacts with O2 in presence of heat, or it has to be heated. You get corresponding CO2 plus H2O, 6 CO2, okay. And H2, okay. It becomes 15/2. So this is the combustion reaction of benzene. So we have discussed all the different type of reactions of benzene today, okay.